Okay, so we have an exam on Wednesday. Today, I will go over any questions you have on the review for the exam. Okay, so exam is going to be the same format. Okay, as before. You need to make sure that you submit your work. If you don't submit your work, I'm going to take points off. I'm going to deduct points if you don't submit your work. So you can't have just answers only. Okay. Back, you savages. You're barking at shadows. Stop with the barking at the shadows. Okay. Okay. So at this point, I'll open it up to questions. My pen. Right there. Okay. So you feel free to ask me any questions you want in the chat box. Okay. Any of these you want to go over, let me know.
Number 5.
Number 5. Sounds good. Okay, ooh, the sprinkler one. Yes, I like this one. Okay, an agricultural sprinkler distributes water in a circular pattern with a 100-foot radius. It supplies water to a depth of E equals negative R, I think. Is that a T or not? I'm not sure. Whatever it is. Okay. The distance of blank feet from the sprinkler. The distance of blank feet from the sprinkler. It supplies water to a depth of E to the negative R feet. Okay, that's fine. Per hour. Oh, at a distance of R. Well, that was weird. R feet from the sprinkler. Okay, so it is an R. Okay. What is the total amount of water supplied per hour to the region inside the circle of radius 15 centered at the sprinkler? Okay. Let's see what we get here. Okay, so it's going in a circle, so I'm going to assume that I'm going to use some form of polar coordinates here, since we're dealing with circles. So circular pattern, water in a circular pattern of radius 100 feet, right? Circular pattern. Let's see what we get here. So we've got this circular pattern, right? It supplies water. So I'm going to go like this. I'm going to draw it like this. There's my circle. And there's a depth here, right? So there's a depth. And the depth, as R gets bigger, the depth gets smaller, right? Because isn't E to the negative R 1 over R, E to the R, right? So as R gets bigger, the depth gets smaller, which should make sense, right? That should make sense. That as R gets bigger, Okay, as we're further away from the sprinkler here, the sprinkler is going to be like sprinkle, 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 sprinkle. Okay, and as we're getting further away, we're going to get less saturation in the soil. Maybe we got something going on like this, right? Okay, so it's just, we know that it's less depth as we go, right? So, and the sprinkler is going to go all the way around, right? And it's going to saturate the soil closer, and then it's going to be less saturated on the edges, more saturated. So it seeps down into the soil. Okay, there, and then I don't want to do this. Let's bring that back. Let's bring that back. Let's go just below here. This is where it's getting wet, right? So it would be below the soil. Okay, top of the soil and below it. Oops, too much. Again, too much. Okay, so we'll say that this is, okay, some sort of angle. I really want to start here, but it's kind of hard because of the picture that I drew. Okay, but okay, so this is 2 pi, right? This is 0 to 2 pi. Okay, so we want it, basically it's just a dr d theta. This is e to the negative r, that's how much water is being saturated in there, right? Okay, and then dr d theta, okay? So we're already given the units, or the depth in terms of r, and so we don't have to convert here. There's no conversion to xy. We're given it in polar coordinates, so we're going to stay in polar coordinates. Okay. Okay, it says, what is the total amount of water supplied to the region inside a circle of radius 15? Okay, so we're not going all the way out to 100. We just care about what happens, okay, up to 15. We want to know how much water is being saturated from 15. So this is just going to be 0 to r, or 0 to 15. And then this sprinkler goes out around in a circle. So that's 0 to 2 pi. Okay. So this is going to be negative e to the negative r from 0 to 15. So this is going to be 1 minus e to the negative 15th power, 1 minus 1 over e to the 15. Okay, and then d theta, you're going to multiply that by 2 pi. So, yeah, and that's going to be approximately 6.28 cubic feet. What is the total amount? Yeah, cubic feet. Okay, because we got feet, and then we do a double integral on that foot, and that's going to give us volume, right? So a double integral gives us volume. What's the volume? Okay, what is the total amount of water supplied per hour? What's the volume of water per hour? Okay. Okay, if the depth in feet per hour, so this was a rate. If the depth of feet per hour goes out at a distance, so in 1 hour it would be, you know, this amount, and then the next hour would be another amount. And so we're actually finding the volume of that rate. So this is going to be volume per hour. Okay, that's going to be the volume per rate. Okay, what is the total amount of water supplied per hour? Yep. Okay, any others that that you want to see done?
Yeah.
I'm sorry, I didn't catch that. Uh, 12. Okay, Erica says 12, please. Thank you for the please. That's nice. Maybe you had good parents there to teach you manners. I don't know. So maybe you either had really good parents or really bad parents. Or maybe just really good elementary school teacher. Okay. Question 12. Okay. It says determine whether to use polar coordinates or rectangular coordinates. Well, that one's kind of a no-brainer on question 12 here, right? So, okay. So, I mean, we've got these two circles. I would definitely be using polar coordinates on this. Okay. So now, are we given it in polar coordinates? No, we are not given this in polar coordinates. How do we know we're not given it in polar coordinates? The expression part, well, I could even tell from the graph that we're not given in polar coordinates. Yeah, look at the, Jose says, look at that it's an XY graph, right? So I could extrapolate some polar coordinates from this XY graph, but right, we're not just, so when I do this, I'm gonna have to say, well, write the expression for the integral. Okay, so this thing is gonna go from what? This is gonna go from f of r theta, right? Which is really gonna be x and y. So what's x? X is r cosine theta and r sine theta, right? X, y, and then we've got our r, dr d thetas. Okay, so now really all we want is the you know, to evaluate the integral where f is a continuous function, blah, blah, then write the expression. So use polar coordinates to evaluate the integral dA. And so what's a in this case? What's dA? Well, it's this area here. So we're integrating over this area, okay, with respect to polar coordinates. So, well, what is this? This is going to be r going from 2 to 6, and then theta is going to go from 0 to pi. And that's it. That's number 12. Okay. You can't go any further because they don't give you, they don't give you what the function is on this one. Okay, number 11. I was asked for number 11, I think. Yeah. Okay, evaluate the double integral where r is a region bounded by these graphs. Oh, you're welcome. See, she says please, and then she says thank you. She definitely watched, like, I don't know, maybe Barney when she was younger or something. I don't know. So some sort of purple dinosaur that tells you how to say please and thank you. That's good. That's good. You're very welcome. Okay. I had a little bear when I grew up. A little possessed bear that used to teach me please and thank you. His name was called Teddy Ruxpin. He'd be like, besides go say thank you to mommy. He would wake up at night too, freak the hell out of me. He'd be like, suddenly turn on at 3 o'clock in the morning. Like, this thing's possessed. Anyway, this little animatronic bear. Yeah, exactly. Teddy Ruxpin. Okay, he was a cute guy. I think he had ulterior motives. Okay, like you are not safe. Number 11. So bounded by these graphs, right? Okay, so what are these graphs? We got to find out what our limits of integration are on this. This one's a parabola. One's a parabola that goes through these points here. Okay, so this is number 11, by the way. Okay, parabola goes through those points here. And then we have this thing that goes through 1, 2, 3. Okay, so 3 up 3, and then up 3 again. 1, 1, 2, 3, up 3. Actually, no. 1, 3. So got this like slopey thing going here. Slope. Right? So up, no, that's not right. How is this looking? This is number 11, right? Oh, it's negative. Oh, it's negative. What am I thinking? It's negative. Okay, so it's negative x plus 3. Okay, 1, 2, 3. There we go. Okay, whoosh. And so we've got this guy. There we go. That's much better. And this is this. Where's this guy? This guy's at 1, 1. No, 2, 1. This guy's at 2, 1. Right, that guy's at 2, 1. So is the other one at 2, 1 as well? If I plug in 2, do I get 1? Yes, I do. That's where they intersect. So they're going to intersect here. Okay. So negative 1, 4 will be an intersection, I believe. Maybe not. Where are the intersections here? Let's just set these equal to each other and solve. Negative x plus 3 is equal to x minus 1 squared. Negative x plus 3 is equal to x squared minus 2x plus 1. Okay, so then this is going to be x squared. This is going to be minus x minus x, and this is going to be minus 2. So it's going to be negative 2 and 1. Okay, so that's not a point, by the way. That's x equals negative 2, x equals 1. Okay. And so no, positive 2 and negative 1. Sorry. Positive 2 and negative 1. So what happens when you try to skip steps? You're just like x minus 2, x plus 1. There you go. And then x is negative 1. So what happens when I plug in negative 1? I get 4. Yeah, negative 1, 4. Yeah, I was right. Negative 1, 4, and this guy is at 2, 1. Okay. So yeah, let's do a vertical slice here. Okay, and we're going to say that the top function is going to be what? The top function is going to be my negative x plus 3. The bottom function is going to be this x minus 1 squared. And then where do the x values go from? Well, they go from negative 1 to 2. That's negative 1 to 2. Okay, of what? Of 3x squared dy dx. Okay, so this is going to become 3x squared y evaluated from x minus 1 squared to negative x plus 3. Okay, nice, nice, nice. Okay, go over here. Okay, and so this becomes 3x squared times negative x plus 3 minus 3x squared times x minus 1 squared. Okay, I'm going to multiply all this out. See if I can get anything to clean up here. Okay, so distribute this. This is negative 3x cubed plus 9x squared. Okay, this is going to be negative 3x squared times x squared plus, minus 2x plus 1. Okay, let's distribute this guy. This is negative 3x cubed plus 9x squared minus 3x to the 4th. That's nice. Plus 6x cubed minus 3x squared. Okay. So this becomes, I'm going to put this in order, negative 3x to the fourth. This is going to be plus 3x cubed, because that's going to combine with that. And then plus 6x squared. Yeah, plus 6x squared. And that's going to be integrated negative 1 to 2 dx. Okay, so this just becomes a pretty easy integration problem at this point. This is negative 3/5 x to the fifth plus 3/4 x to the fourth plus 6/3 x cubed from negative 1, sorry, from negative 1 to 2. Okay, so if I plug all this in, I mean, it really becomes a calculator problem at this point. But we get negative 3/5 times 2 to the fifth, okay, plus 3/4 times 2 to the fourth, plus 2 times 2 cubed, okay, minus negative 3/5 times negative 1 to the fifth, plus 3/4 times negative 1 to the fourth, plus 6, or sorry, plus 2 times negative 1 to the third. Okay, so, well, I don't know how much you want to do this on by hand. This 3/5 is going to be 0.6, and so we end up with 32 times 0.6. So this is negative 32 times 0.6. Okay, this is going to be 16 divided by 4 is 4, plus 3 times 4 is 12, plus 12. This is going to be 8 times 2, which is 16. This is going to be positive 0.6. So this is going to be minus a minus a minus. Minus, minus, minus. So that's negative. Negative 0.6. Okay, and then this is going to be positive 3/4. So that's going to be negative 3/4, which is 0.75. And then this thing's going to be a negative 2, but then we're going to distribute the negative, so it's a positive 2. Oosh. Okay, so yeah, again, I don't know how much you want to do this by hand, but I could factor out a 0.6 if I wanted to. 6 times, this is negative 33. Okay, times 0.6. We got negative 32 there and a negative 1 here. Okay, and then 12 and 12 and 16, that's 28 plus 2 is 30. That's plus 30. Okay, and then minus 0.75. Kind of interesting. So again, at this point, again, it's just a calculator problem. So what is this thing? 0.6 times 33 is negative 19.8 plus 30 minus 0.75. So negative 19.8 plus 30 minus 0.75, 9.45. There we go. That was number 11. Would I be able to go over number 14? Absolutely. I would be able to go over number 14. Thank you for using your manners to homework. Okay. So Wendy. Oh, it is Wendy. Oh, you changed your name to Wendy. That's, I mean, you changed it in the chat. That's good. That's good. I think there was there a Disney? Was there a Disney movie, Disney character named Wendy Wu? I thought it was. Like in the late 90s, maybe. Homecoming Warrior, yes. Yes. Yes, thank you, Armando. There was. I have watched, in my life, I have watched way too many children's characters in my entire life. Because before, I grew up in the 80s, and then they were like, you could only watch Saturday morning cartoons. And then in the 90s, they came out with like afternoon cartoons. They were like on KCAL. And you know, I grew up with, I don't think I had cable until I was like 13 years old. So my parents, we had like channels 2 through 13. That was it. Because we were not wealthy. My friend across the street, he had like all the movie channels and stuff like that because he was rich. But me, no, we didn't have any of that stuff. So, and I come home and I watch my DuckTales and my Chippendales Rescue Rangers. So, and I finally got cartoons in the afternoon, which was good. And then they tried to put cartoons on KTLA, which is Channel 5, and all those sucked. They totally sucked, right? And then there was Darkwing Duck. That was awesome. I love my Darkwing Duck. That was good. Those were good. And Tailspin, Baloo. That was a good one too. Watch that one. And then I got married when I was like 26. And then we started watching, what did we start watching? We started watching Thomas. Started watching Thomas the Tank. But then we were also watching Rugrats. Remember that? Rugrats? So you guys are probably too young for this. To watch the Rugrats? Maybe not. If you're in your mid-20s, you remember Rugrats. I assure you. Mid to late 20s. So those were good times. And the Wild Thornberries, remember that? Remember the Wild Thornberries? Remember that too. Yeah, exactly. Those were good times. And then Hey Arnold, remember Hey Arnold? That was a good one too. Hey Arnold. And then what happened? And then what happened after Hey Arnold? SpongeBob. That was like 2000. SpongeBob shows up on the scene and just takes the cartoon world by storm. Cat Dog. Yeah, that was a good one too. That's okay. Anybody remember Ren and Stimpy? You guys are probably too old for that. That was a old one too. So, Powdered Toast Man. You trying to take a picture of my thing here? Just hand it over. Courage the Cowardly Dog. Yeah, that was great. I liked Courage. Courage is great. It's like an anagram for something. I don't know. It's just exact. Anyway, let's do number 14, shall we? What? What did you say? Anagram. An analogy, not anagram. Anagram is when you mess them all up. So it was an analogy. What was Courage the Cowardly Dog an analogy for?
Well, he's a scared dog.
He's a scared dog, but it's like a nightmare. He's like living in a nightmare.
No, it's the world in a dog's point of view.
Oh, it's the world in a dog's point of view, right? Everything's scary.
Like the monsters are always cats or some other kind of being.
Right.
He thinks that he lives isolated because he's a home dog. So he doesn't know the outside world.
He doesn't know the outside.
He's afraid of it.
Right. Yeah.
And the only thing he can attach to are the people he live with, right. and they're old, so they can't really love on him as much as. So it's all the world in dog's point, in a frail dog's point of view.
Yeah, it makes sense. So there you go. There's if you didn't know. So that was my son, by the way. So yeah. So anyway, but again, way too much of the And then, oh, and then it was all about My Little Pony after that, and all the bronies, which I think those bronies have mental issues myself, but you know, anyway. So let me just, anyway. Yeah, exactly. We're living like Courage right now with COVID, exactly. So the outside world is scary.
The constant here we go outside.
Exactly. Do you want to say hi, Josh?
Oh, okay.
You good? He lives in his pajamas, by the way.
What do you do?
Shush. Shush.
That's professional.
Shush. Don't give away my secret.
You sleep more than I do.
Yeah, well,
So
because I'm old. I need my sleep. Okay, sketch the solid bounded by the graphs. These graphs. Okay. Z equals x squared and z equals x squared. These are paraboloids, by the way. And then use a triple integral to find the volume of the solid. Okay. So we're going to sketch these paraboloids here. What does the paraboloid look like? We're going to be at the point 0, 0, 0, right? So 0, 0, 0. Okay, so it's going to be like so. I'm going to get this paraboloid here. Okay, 0, 0, 0 will be a point on my paraboloid. What happens when I do 2, 2, and 2? If I let x be 2 and y be 2, well, let's just do 1 and 1 first. If x is 1, y is 1, then z is 1. Okay, so x is 1, y is 1, then z is 1. So basically at 1, we are on the unit circle. Okay, at 1, we're on the unit circle here. Boom. Right? At 1, we have the unit circle. What about, what would z have to be for us to be, when z is 4, we're at a circle of radius 2. That's interesting, right? Because r would be r squared, right? So if z is 4, then r is 2. Oh, okay. So this is 4, and the radius here is 2. Okay. Well, if we start at 8, and we invert this, if we start at 8 and get it inverted, well, we're going to end up actually hitting the same spot. This is going to be a circle of radius 1, and then this will be a circle of radius 2. So the volume between these two are just the bottom. This is the bottom. This is the bottom surface, and this is the top surface. That's the bottom surface, and that's the top surface. Okay. We just want to find the volume smashed between these two surfaces. Well, I'm going to use polar coordinates to help me do this. Okay. So what do we need? We need, well, not polar coordinates. I'm going to use spherical coordinates to help me do this. Okay, spherical coordinates, not spherical. I keep screwing up. Cylindrical. I want cylindrical coordinates. So let's use cylindrical coordinates. Okay, because that's polar coordinates, but with a z-axis. Cylindrical coordinates. Okay. Okay. So, I mean, I was forced at gunpoint to watch My Little Pony with my daughter. Now, granted, it was a toy gun, so there was no physical harm to me. But she basically said, "You're going to watch this show with me." And so I was like, "No, I do not want to watch this show about Pinkie Pie and Applejack and, you know, Twilight Princess and, you know, Rarity and you know, all these ponies and all their, you know, drama, their female drama." So she was like, "No, you're watching with me, Dad." And I guess that's what dads do. They just kind of suck it up and watch the My Little Ponies with their daughter. So it's like, that's fine. It's all good. Let's use cylindrical coordinates here. Okay, let's do that. Okay, so Z, we're gonna do, now we were given this in X and Y, right? Weren't we given these in X and Y? We were given these in terms of X and Y, so we're gonna have to change these to d Z, dr, d theta. So if I change from X, Y to dz, dr, d theta, then I have to put an extra r, right? Because we're changing from x, y to r theta. And then what are we using as our function? Well, we're just finding the volume. We're not finding the volume under a certain surface, okay, or under a certain function, or you know, we're finding the volume. So we can actually do a triple integral here on 1, right? The function would be 1. Okay, so what's Z going from? Z is going to go from what to what? Well, what does Z go from? And you might think, well, it's just going from 0 to 8. Well, sort of, but not really. If you were to look at, say, this slice here, okay, what is Z going from? Okay, it's only going from 0 to 8 on the axis. Okay, but what is Z going from? It's going from the bottom function to the top function. Well, what is the bottom function? Well, the bottom function is 8 minus x squared minus y squared. Well, so what is that? Let's just write that. 8 minus x squared minus y squared. Now, what's the top function? The top function is Z equals x squared plus y squared. Is that right? Yeah. Okay, bottom to top. Bottom to top. Yeah. Okay, so x squared plus y squared. The bottom, yeah. No, the bottom, wait, let's do this wrong. The bottom function is x squared plus y squared. That's right. It's x squared plus y squared. The top function is 8 minus x squared minus y squared. There we go. Yeah, that's what happens when you don't label these things. This is 8 minus x squared minus y squared. This is x squared plus y squared. Okay, but in terms of r, we'll deal with that in a second. What's r going from? R is going from 0 to 2, right? So 0 to 2, right? Or, yeah, 0 to 2. Okay, that's r. Not rho. Okay, if it was rho, if this was spherical coordinates, that'd be a completely different thing. Okay, but r is just a two-dimensional radius. Okay, and that's going from 0 to 2. The furthest value that it goes is 2. So 0 to 2. Okay, and then theta goes from 0 to 2 pi. Okay. Well, I can change this. This is going to be 0 to 2 pi, 0 to 2, and then change to polar coordinates. This is r squared to 8 minus r squared. This is r dz, dr, d theta. So let's do this. Let's integrate with respect to z. That's going to be rz from r squared to 8 minus r squared. Okay, plug this in for z. Okay, so r times 8 minus r squared minus r times r squared. Okay, that's kind of interesting because what happens when I distribute and I get 8r minus r cubed minus r cubed. Okay, so that's going to be 8r minus 2r cubed. 8r minus 2r cubed. Okay, and now I want to integrate with respect to r. 0 to 2, 0 to 2 pi. Okay, dr d theta. Okay, so this just becomes 8 over 2r squared minus 2 over 4r to the 4th from 0 to 2. Well, that's nice. This becomes 4 times 2 squared minus 1/2 times 2 to the 4th. Okay, and so this becomes 4 times, this is 4 times 4, which is 16, minus this is going to be 16 divided by 2 is 8. That just becomes 8. Okay, and then we're going to integrate that from 0 to 2 pi with respect to theta. Well, that just becomes 8 times 2 theta, which is 16 pi. I'm sorry, 8 times theta, which is 8 times 2 pi, which is just 16 pi. That's it. That's 14 right there. Okay. That's good. Some good stuff.
Can you scroll up just a little bit?
Scroll down or up?
Down. Sorry.
Okay.
Thank you.
Okay, anything else you want to see done at this point? Okay, question 8. Okay, let's see, what does question 8 say? Okay, use spherical coordinate to find the volume above the cone and inside the sphere. This is like the ice cream cone one, right? This is very similar to one that we did in class, I think. Maybe not. Okay, so we have, write this over here. Okay, we have number 8. So we have above the cone. Okay, above the cone. Okay, this. And inside the sphere, x squared plus y squared equals 2az. Okay, so this is a, and this is 2a. Okay. And then we have this sphere like so. Okay, so sphere, sphere. Okay, I'm thinking that that's A. Now why? Why is that A? Thinking, because I want the radius to be 2az, right, on this thing. No, I don't want the radius to be 2. Yeah, 2a is z, right? And so when x and y are 0, so when x and y are 0, we have z squared equals 2az, okay? And so z equals 2a or z equals 0. Okay, yeah. So when x, y, and z, so it's either 0, 0, 0 or 0, 0, 2a. Yeah, because 2a times 2a is going to be 2az. Yeah. So 2a here, right? 2a. So then what's this going to be? This is going to be a radius of a, right? This is going to be a radius of a, which makes sense because this thing then here is going to be, it will go out a and up a, right? So out a, up a. So That's nice. Why? Because this is a cone. Why? And the cone again is z squared equals x squared plus y squared. So if right, so if the point on this cone at which z is a, right? So a squared. So that's x squared plus y squared is equal to a squared, right? So yeah, on that cone there. So we will have increasingly larger circles, larger radii, but when z is equal to a, then the radius is a, yep. And so we get this cone created from these concentric circles. Okay, and so we want to know what's the volume of the ice cream here, right? With sprinkles. Sprinkles here. Sprinkle, sprinkle, sprinkle. Okay, so no, we're not taking into account the volume of the sprinkles. It's not going to happen. Okay, so we have z squared equals x squared plus y squared. Okay, and so we want, again, the volume of this thing. So before we used spherical coordinates, I believe, in class to calculate this thing. Okay, and that's what we're going to do again. Okay, so it's basically the same question that we did in class. Okay, so we have, okay, rho squared sine phi. Okay, that's my integration factor of d rho d theta d phi, or was it d theta d phi? Maybe it was d theta d phi. Okay, d rho d theta d phi, and this is my integration factor. And then this thing goes from 0 to, before we had a cosine or r cosine theta, you know, or whatever. This is going to be 2a cosine theta. Okay, or sorry, cosine phi. Yeah, cosine phi, because it's this angle here that I'm looking at. Okay, that's what rho is going from. Okay, theta is going to go 0 to 2 pi. And phi is going from 0 to pi over 4, I believe. Yeah, 0 to pi over 4. And again, just look at the one that we did in class. It's the exact same thing. With the exception that you get an A here, and you're going to get twice as much. I think before we got, I don't remember what the dimensions were, what they gave us for A before, but you know, basically it's the exact same thing. As soon as you plug this A in, you can pull that A all the way out to the very front. Yeah, I mean, once you integrate this with respect to rho, it's just 1/3 rho cubed sine phi, and then you're going to plug in this 2a cosine theta and 0 for rho, 2a cosine theta. So, well, yeah, once you plug this 2a in here, it just becomes cubed. So we get an 8/3 a cubed, I think, right? 8/3 a cubed. Okay. Cosine, this is not theta, this is phi, sorry. Cosine phi cubed, sine phi, right? And then we're going to do d theta, which all that's going to do is multiply this by 2 pi. So that's just going to give me 16 pi, and then just integrate 0 to pi over 4 for phi, d phi. And again, just use a u sub of cosine, and you should get the value there. Okay, so you can pull this stuff all the way out in front. because that's just a constant, 16 pi over 3 a cubed. This is going to go from 0 to pi over 4. Cosine cubed phi, sine phi. This is like a pretty easy Calc 2 problem. Okay, to do that one there. So what do you get here? You're going to get, I don't know what you get here. So this is just a u of, this is just a u of, this is going to be a 1/4 u to the 4th, right? So u is cosine theta, which means du is negative sine theta, so you're going to get a negative here, right? Okay, if u is cosine theta, then this is going to go from 1 to radical 2 over 2, I think. So you can just plug those in. It cleans up pretty nicely because of that 4th power there. I think we end up getting like 1/4 or something. I don't know. So like this negative 1/4 will cancel with this 16. That will make this 4. I'll make that 1, right? And then, so we would get a negative pi over 3a cubed. And we're just going to evaluate u to the 4th. That's 1/2. 1/2, right? To the 4th power minus 1. So that's going to be negative 1/2. So that's going to be what? I don't know. I think I'm doing this too fast. Let's see what we got here. Pi over 4, blah, blah. That's 1/2. So that's 1/6. Let me go back here. What did I do wrong here? Maybe that's not 16. Maybe that's 8. I did. Oh, I had a 16 because of the 2 pi. That's right. Because of theta. Oh, that's right. Should be right. And then let's go back to this step here. Zero pi over 4. So this is make sure I plug this in correctly. So this is 2a. Plug in 0 is nothing. So cosine cubed. Yep, that's right. Cubed. That's a cubed. That's, yep, that's that. And then integrate with respect to theta. There's no thetas, so that's 2 pi 16. Yeah, okay. I should be able to pull that out. Okay, so let's try this again. So u equals cosine theta, or cosine phi. Du equals negative sine phi. So this becomes 1. Okay, so I'm going to go from 1 to radical 2 over 2 of u to the 3rd du. This is a negative. Okay, so then this becomes negative 1/4 u to the 4th from 1 to radical 2 over 2. So this is negative 1/4 okay, times radical 2 to the 4th power minus minus 1 to the 4th. Okay, so this becomes negative 1/4. This is going to be, oh, that's where I screwed up. Oh, okay, so this is 1/4. Is it 1/4? Yeah, because this is going to be 4/16, which is 1/4. That's 1/4 minus 1. So this is negative 3/4. Okay, and times a negative 1/4. That's going to be 3/16, which is going to cancel with the 16 over 3 pi pi a cubed. Bump, 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 and it's pi a cubed. Oh, there we go. Okay, so it was this right here. I put in a 1/2 instead of a 1 because I was thinking squared, not 1/4. I mean squared, not to the 4th power. There we go. Okay, so that's good. That's good. Okay, so I actually did the whole thing. Okay, did the arithmetic as well. Okay. Yep, no homecoming this year for anybody. No one's coming home. So sad, so sad. No winter formal either. It was canceled. We'll see if prom happens. I mean, that would be pretty sad if prom was canceled twice in a row. 2 years in a row, no prom. Social distancing though. I mean, could you imagine going to a dance and having to like dance with your partner 6 feet away? You're like, leave room for COVID. Social distance. Social distance, all you teenagers. Everywhere. It's good. Maybe, hey. I don't know. Okay. Any others? Any others that you'd like to see done at this point? Are we good? Going once? Going twice? Okay, well, we will stop it there then. If we're good. If you're good, I'm good. Okay, and then I'll see you on Wednesday for the exam. What do I want to say? Oh, here it is. Probably, I think thank you. I think I probably responded if you sent me something. So I can check. I think you sent me it through Canvas, honestly. That's what I recall. You're welcome.
Thank you.
Hey, you're welcome. See you later.
Bye. Thank you.
Bye. Okay, so let me go to my canvas here. Yeah, it had to have been through Canvas. I don't have anything in my email. Again, I was pretty sure I responded to you, but maybe not. Yeah, it says, yeah, I got it. I responded. So it's good. That was October 22nd. I think, no, October. Yeah, October 22nd. Oh, maybe I didn't respond. So I just, oh yeah, I got it. Thank you. Yeah, and if you need an extension on the homework, let me know. So it's not an issue. Oh, I did grant you one in WebAssign. So yeah, we're good. We're good. Yeah, yeah. So I just figured you'd go into WebAssign and see that it was granted. Okay. Does that make sense? I don't remember how far in the future I granted it. Let's go to messages. Go to messages. Here we go, answered. Oh, maybe you didn't send me one. The last one I have is from October 22nd. But it was for two other people. So yeah, if you just want to send me an extension request in WebAssign, that's fine. So no worries. Okay. Are you still there, Erica? Oh, I'm on mute. Was I muted? Can people no longer hear me?